national security. We've got national security and finance experience among other technical co-founders. We did 3 rounds of venture capital fundraising in 2014 and 2013, where we've raised about $14 million to date. And we're 24 employees and growing rapidly. We're hiring great engineers and lots of other folks now. So we just now launched, as I said, our first beta in November. We've been really excited to get the CTO of Wunderlist, Chad Fowler, who coined the term immutable infrastructure. Has anyone heard of this? Okay, great. And Dave Merkel, the CTO of FireEye, ex-CTO of Mandiant, on our advisory board, and they're both really excited about what we're doing. So fugue in music is the repetition of simple phrases evolved over time to create complex compositions, right? And so in computing, we like the term fugue. We chose the term fugue because we regenerate immutable infrastructure over time, incorporating changes, maintaining what's there correctly, and destroying and replacing it for immutability all automatically on AWS. So Fugue is immutable infrastructure realized. This is the kind of stuff companies like Netflix have spent a lot of time and money to build big complex systems to do. You get that out of the box very easily with Fugue. So here's a quote from Chad. The longer a system lives, the more afraid of it I become. An old system inevitably grows warts. They start as one-time hacks during outages. We'll put it back into chef later. The system becomes a house of cards, and you fear any change, and you fear replacing it. And I'll draw an analogy here, which is all of us, right? The reason we still function as systems with fidelity over decades is because we're constantly destroying and replacing our components, right? People think of the immune system as the way that we preserve our fidelity. It's not the primary system. The primary system is cell apoptosis. It's the destruction and replacement of the subcomponents to preserve the fidelity of the whole. And with cloud computing, that can now be done with your compute infrastructure. And that's exactly what we do. We designed this to work within your AWS account. We're launching on AWS, and we're looking at lots of other things as well. We basically can operate on any cloud infrastructure. We had to start somewhere, and AWS was the right place to do that. So the way our high-level architecture works, so first of all, everything we've done is from a security-first perspective. So everything in our stack communicates via asynchronous messaging. There are no open ports and protocols between tiers in the stack. Everything is very, very secure, all the way down to immutable infrastructure itself having some really great security benefits, right? The typical data exfiltration takes 4 to 6 months. Well, if your servers live for an hour, that makes that a much more difficult attack surface for somebody who's trying to steal your data or have an advanced persistent threat. But I'm going to walk through this architecture briefly. So on the left-hand side, you see a composition. A composition is a very simple bit of code. We have written a compiled domain-specific language that looks a whole lot like YAML. For those of you who are familiar with that, I'm going to show this to you in a minute. The reason we wrote a language and have a compiler is so that we could use functional compositional patterns and not big giant piles of script, which is what you end up with if you do just a text file. And if you've ever written code against cloud infrastructure that isn't compiled, a lot of times you find your errors by spending $50 on Amazon, getting 2/3 of the way through your CloudFormation stack, getting an error, and then debugging. So it's great to have compile time, checking of your code to make sure what you're doing is right. And we're going to be doing a lot of interesting stuff with this language going forward. So I'm going to show you all this in more detail. That is communicated via on AWS, an S3 bucket, to our conductor. And the conductor can really be thought of as a operating system kernel if AWS is one giant general purpose computer, right? So the metaphor is in a modern or going back to 1970 when Unix was invented, right? This is the legacy we're building on with all of us on the internet is Unix. From 1970, you needed a kernel to keep track of processes. Well, we believe that the compute instance is the modern process. And yet we don't have a kernel and an operating system to know everything that's going on, manage it, and automate it. So that's what our conductor is. It runs in your Amazon account in EC2. It just takes a simple T2 micro. To run our entire stack in AWS, you're going to spend about another $20 to $50 a month on your AWS account. Not in terms of our cost, but in terms of what we cost to run. So one EC2 instance, some DynamoDB, some SQS, we've highly optimized to make this very inexpensive and efficient to run. We have a client tool, which is a very straightforward statically linked executable on Windows, OS X, Linux. Everything that we ship is statically linked single executables. Really easy to integrate using whatever tool chain you're using now. And then we, through that conductor, we take that composition in. The client tells the conductor what to do, and we build out everything in your AWS environment. We maintain it, and we constantly regenerate it. So I'm going to show you a little bit of this because this is so different than other solutions out there, it's hard to kind of get all at once. But I'm going to start by showing you our command line tool, which is just called Fugue. So if I have a simple composition, where am I? Sorry. I've been a CEO for a year, so my terminal skills are weak. Still saving Emacs though. So this is all the code I need to build an entire small application, web application, with a load balancer, with firewall rules, everything in Fugue. And all I need to do to run this is so what it just did, and this is actually a feature, not a bug. It said must specify username. We actually can use your IAM roles in EC2 instances for doing credentialing for even better security. So what I just fired off into what has been a blank AWS account, you can see now I have EC2 instance performers coming up. I've got a load balancer that was created. I've got security groups. I have IAM roles. Every single thing that you need to run your application is now being built by Fugue. But I'm going to jump over, because it takes AWS a couple minutes to get the instances going, and show you a little bit more about how to use the tool. If I can remember which way my screen is. Okay, so on the left is our Gui Visualization Tool we're working on. This is not part of the beta that's available now, but will be available relatively soon. And on the right is some code, and I just want to show you how simple this is to do. So again, if you've seen YAML before, this should look familiar. We call a particular instance of your application a venue. So in development, there might be the dev venue. So in this case, we're saying this is version 1 of my application in the development venue. I want to run this in AWS's US West 2 region in Oregon, and I have one section of servers or of instances, which I'm going to call dev web. And there I can assign the function of that particular instance type in that section. So in this case, I've just selected an AMI. We're going to have other methods of composition than AMIs. But right now, if you can run something in an AMI, you can Fugue that application. Over on the left, a couple things to point out. One is, well, I'm scaled strangely here, so I'm getting bad artifacts on my UI. Let me reload this real quick. That's better. This is showing a single server instance. This diagram will make more sense in the future as I get into more instances. This is kind of a sped up diagram showing that the lifespan of individual instances. So to get back to that immutable pattern, when you define a particular server and a tone, included in that, in this case from the, come on, go away. There we go. From the library we provide, we're saying the lifespan for it, where is it? Is 60 minutes. So what this is saying, and this is all code that we provide to you. So just like you would have a standard library in C, there's a standard library we're developing in Ludwig, which is this language, such that you can just refer to that. Also, while you're at a language, you can just overload specific fields, unlike you would in YAML or JSON or something like that. So very, very simple, few lines of code, One command, you just saw me run it with the Hello World application, which we'll check on in a second, and it's up and running. If I want to create a production venue, here I might want instead, I might want to reuse a lot of the code I used in dev, but I want 15 M3 larges. And I want to refer to an external database that I'm not fuging, right? So if I'm running an RDS instance or I have an existing database out there in AWS or at any IP address, I can just create a reference to that entity and then point to it using Ludwig code. So in this case, it makes, I think, a little more sense. You can see the server lifespans of these individual instances. The conductor is always checking to make sure there are enough instances serving a function at any given time before destroying and creating new instances. So we're never going to create an outage for your users. We're highly cost efficient against AWS infrastructure. We optimize how we do this replacement strategy. And in addition to the immutable infrastructure patterns in compute, we're also making sure everything you've declared in Ludwig, like your security group rules, your load balancer, are maintained as they were described. So a very common problem in AWS is you have 10 developers, you give them all access to an account, they can step on each other's toes, break things, etc. So with Fugue, really it's just the conductor that needs to be able to have the credentials to build all of this stuff. And your user just needs the ability to write some code and pass it via simple queue service to that conductor. And then that conductor is going to make sure it's how it's supposed to look. So let's go back and see what we've got in AWS now. So I've got a couple of micros running my simple application. And I should have a load balancer with an endpoint. All right, so this is a little Nginx application showing our logo that we had designed for Fugue. If any of you have built even a single-tiered web application with security groups, load balancers, IAM roles, EC2, I just did that in a few minutes. And extending that is very simple. So there are a lot of benefits to this approach. The ability to just program in a simple declarative pattern against AWS, and then be able to employ all those immutable patterns that are so positive for security, maintenance, and fidelity. So we are in beta. If you go to fugue.it, you can sign up for that beta. If you talk to one of the three of us tonight, we're happy to help you do that now. We're also happy to help people who have real use cases develop against it at this point in time. We're just now starting to interact with customers in beta, so it's early days for us. If you go to our website, you'll find our docs are changing every day as we small company struggles to produce these things early days. But please come and try it and let us know. We'd be glad to be helpful. So I'll take any questions. Sir?
So, two questions. Number one, are you familiar with Lambda from
Yes.
Of that? And two, the immutable aspect, do you maintain state or is it stateless? I didn't get the...
Okay, those are great questions. So let me take the second one first.
Yeah.
So the characteristics of immutable infrastructure, they tend to be applied, immutable infrastructure as a pattern tends to be applied to the least stateful or stateless parts of an application. So if, for example, you have a stack where you have a database, and I'll go back to this, you'll notice this database is not moving. Running a database cluster, a relational database cluster, immutably is kind of self-defeating in some ways. Now, you can argue that most of the attack surface of a database is not in the table space, it's in the operating system that's running the servers that maintain that database. So we have experimented with use cases where we can create immutable patterns on things like databases, but that's hard to do at present. But the vast majority of the really large distributed applications that are happening out there are relatively stateless in much of the service stack. So a microservice or a service-oriented architecture, if you've got 20 services running, in general in AWS you find a great many of those are stateless. So that would be the low-hanging fruit for this in terms of learning how to do it. As far as Lambda, Lambda is really a very different sort of approach. Lambda is sort of compute as a service where you're not concerned about your infrastructure at all. And to me, I was reminded of I guess it was in the early 90s, the transputer, right? So if you can only run a function and you only have input and output, your compositional patterns in code look very, very different than if you're writing a traditional program that can keep state and pass it around in different ways. So I think Lambda is really cool. Right now, we have not created Ludwig to use Lambda, but we're thinking about it.
You just talked about relationships with OpenStack and Docker and all the other things that people are using for private cloud, public cloud, scaling that.
Sure. So you'll notice a key difference about what we do and what I think anyone else does is we fully automate your runtime and then operate it. So where there are a number of things out there, AWS CloudFormation, for example, where you can kind of write a script to do some stuff and then it's done. That's a much easier problem than constantly being aware of the state of everything in your cloud environment and making sure it's conformant to declarations. So the reason we chose to launch on AWS are severalfold. One is we have one surface to write against. There are no reasons our patterns couldn't be applied in future to things like OpenStack. We do a lot with software-defined networking, and there are a few real-world implementations of OpenStack that have API-driven SDNs that the actual users are using in that way. You tend to see people still building semi-manual network environments where we prefer to have full automation, but we are looking at things like OpenStack and other on-prem environments. Yes?
This notion of, I've got a two-part question. So the first part is to do with immutability, right? This notion that you want to keep every component in, on the operating system, machine configuration, etc., the same, and not be able to change that. How does that gel with, security patches that you have to go deploy because, there's some bug in SSL, and now you have to go past the AMI, and you've got to maintain the machines constantly. So really, there is a mutation there because you're applying a patch and you are changing, components of that particular instance, right?
Well, the notion that I think immutable infrastructure, and a friend of mine coined the term. Yeah. So I like the term on that level. It immediately tells a programmer what's meant, but it is fiction. There is no such thing as immutability. Once an instance is here, it is mutated. The real key difference, though, is don't patch the servers, replace the images. Right. And there are lots of, right now we do that with AMIs. We're working on a lot more interesting ways to do that. And I'm going to come back to your Docker question that I forgot. So of course you need to maintain and update what you're doing in your infrastructure. We believe the right way to do that is not by running Chef against 10,000 nodes and hoping they all run properly, but rather by making one good instance and rolling out an automated way with a conductor.
Sure.
Does that answer the question?
Yeah, the other question I had was, in terms of orchestration of all this, how is this different from kind of OpsWorks or really any platform as a service offering? Because I see the value in this tool when you're trying to do infrastructure as a service and you've got various different components you want to kind of orchestrate together. And OpsWorks is an offering from Amazon to kind of prepackage that in a way, maybe not as good as your solution, but something similar. And then services like Beanstalk. Right? Sure. So if all you have to do to launch an application on Beanstalk is you create a WAR file or your Python application or Rails or whatever, you push it into the container, and Amazon automatically binds the container, the load balancer, the whatever the hell, database persistence layer, everything else for you, and manages that for you in those types of patterns.
Yeah, that's a good question. So the tools you mentioned are really deployment tools.
Sure.
And they are in that category of things that do something once and then occasionally can do operations that are user-driven. So I'll give you one use case of an early test customer that is going to be adopting this. They were using Beanstalk to spin up clusters, which sometimes fail.
Sure.
In which case there was manual intervention required to do so. So in an automated scripted environment, that's not a great scenario to begin with. And then once they had that infrastructure, they would get noisy neighbors, they would get other kinds of error conditions in the cloud that are kind of native to the cloud environment. And then they get paged at 1 in the morning because something had drifted off. Hence the immutable infrastructure pattern. So none of the things you're talking about, there are 2 key differences. You can think of us as a deployment solution, but that's really a tiny piece of the picture. We are a kernel that's operating that cloud environment all the time, and we're constantly maintaining it and we're constantly replacing. So that immutable pattern, there's a reason why it's really getting popular with people who deploy at large scale. And again, I'll point to Netflix as an example of this. I was talking to one of their senior guys, and he looked at what we were doing at reInvent and said, I think this would have done about 80% of the work we had to do in-house to deploy at the scales we're at on AWS. So there's a lot of deployment solutions. Also in those deployment solutions, they tend to cost money if you make mistakes.
Sure.
And when you get to really large scales, that can be consequential. Yeah, so anything else I could talk about is going to give away product roadmap. I'm not going to do it. But as far as Docker, right now we operate on an AMI basis. So we have experimented ourselves with using Docker for dev test and then baking an AMI from that. At the end of the day, to us, it's just a deployment unit. We are still deciding exactly how and where we're going to support other deployment units than AMIs, but we'll have a lot of things to talk about in the next couple quarters.
I'm struggling a little bit with why it helps to create the exact same image on the new computer. Because computers don't get tired. It's just metal. So why aren't you just repeating the exact same mutations and complexity of sets and policies and scripts and all that other stuff? So you just don't get copied over?
So it is unusual for CPUs. Hardware, I would argue, is truly engineered. Most software is authored, right? In other words, hardware, you tend to kind of know the bounds and failure states around these things, and the companies have gotten very good at making sure it's right most of the time. That is simply not true in software, and we see that all the time. And so what we've got now in modern enterprise software is tens of millions of lines of source code, where we know for a fact the average rate of bugs in 1.0 software is about 1 per 10 lines, and by the time you get to version, say, 3, it might be 1 per 50 lines. So you've got millions of lines of bugs, all interacting over time. That is the current state of a Linux, Unix, or Windows operating system running out in the world. So the term you see out there is bit rot. It is real, and it's not because the machine's wrong. It's because humans are wrong in aggregate over years. And so the immutable infrastructure patterns are very beneficial to mitigating that reality. That if you have a machine that is running for an extended period of time, it is no longer doing what you said you intended it to do, guaranteed somewhere. And so rather than try to solve that, which has proved an absolutely intractable problem in software, right? I mean, you can go back and read Edgar Dijkstra complaining about this in the 1960s and 70s, that our software was terrible because we weren't writing it in any way we could prove it. In some ways he was right, but we would probably be still using 1200 baud modems if we'd listened to it. But so we have this big stack of bad, messy software in some ways, and the mitigation strategy now is accept that fact, move on, and do that by replacement on a high frequency basis. Does that help?
I guess we can say it offline.
Sure. Time for one.
You're talking at the operations level, the kind of software where I'm kind of struggling with the same issue.
Where are you drawing the lines of what can move to?
Well, exactly, at a much smaller scale
Mm-hmm.
than some of the businesses that you mentioned. But so say the fundamentals of what we build our software on top of is where the kinds of problems are that you're solving.
I'd say both. I've certainly built applications that develop intermittent bugs after days because of memory leaks in libraries I inherited through Java frameworks, and where I'm going in and doing profiling for weeks to figure out what's going wrong, and then I find out it's in some open source framework I downloaded, and so now I could contribute that back, but it's there. So this is an endemic problem. Sometimes it manifests in the code you're writing, but very, very often, more often than not in my experience, it's something you inherit somewhere from the operating system, the frameworks, the language stack libraries,
So
etc.
if you have memory leaks somewhere in your stack that, say, on a weekly basis is going to run out of memory because of the nature of this memory leak, if you're actually rebuilding that every hour, then
That's true, and there are all kinds of other things that are nasty, other than memory leak bugs and so on, that happen over time. For example, advanced persistent threat attacks, bad actors getting into your system and staying resident. You cannot typically detect these things. So there's all our philosophy to computing, and one that's becoming much more common in the industry, I think, is don't trust anything once it's seen air, for lots of reasons. And that's kind of the fundamental reason for immutability, is once you've turned a system on and exposed it to traffic, it is now rotting. And it's a question of when, not if, it will get into a bad state for one reason or another. Hence Chad's quote about, I don't trust things the longer they live. Yes, that was the last one, I'm sorry.
Yeah, you'll be around, right?
Huh?
You'll be sticking around.
Yeah, we'll be around. So thanks much. Thanks.